Okay, thanks so much for that intro, and thank you all so much for being here. So Hyperscale is a project that I built to make a little less annoying one of my favorite hobbies, baking. So you could say that I've been baking for a while. I'm there in the center. And I started out by really doing some of the most crucial tasks of baking, such as sampling. Um, but as I aged and baked a little more, I became a little more involved in the process and started doing kind of things that are a bit more complex than just cookies. So this is a cake that I made in college for one of my living groups, and it's definitely more complex, 6 layers, fun theme going on. But as you can maybe tell, I started out a little sloppy. This is not the most architecturally sound cake that has been out there, but I worked on it. I got better over time. I refined my technique. So here's, for example, is a nice brown butter cake with toasted sugar. I learned how to properly level each layer of the cake so that it ends up flat rather than totally domed at the top. And it has a nice crumb coat on the outside with buttercream before I put the final layer of buttercream on the outside so that there's no crumbs ending up in the frosting on the outside. So then at the start of the pandemic, as I was coming to a close in college, I really got into French baking. I was with a friend who was French and really got interested in that scheme of things. So this is a clafoutis, which is a kind of eggy, custardy pastry with cherries typically. This isn't actually eggy because it's a vegan version, but has that at least custard vibe going on. Um, so something about French baking is that it really depends on a few core techniques and recipes, like even more so than American style baking. And then you put endless variations on top of them. So like macarons have a standard recipe that then you doctor in various ways. Um, and like among French baking, I think nowhere is this more true than with choux pastry. Choux pastry is a type of dough that's used for cream puffs, eclairs, and a lot of other pastries. So here are some eclair shells that I made. Choux pastry is fun because you actually cook it on the stove before you end up putting it in the oven. That cooking process in the stove gelatinizes the starch and lets it absorb a ton more water, so that then by the time you actually stick it in the oven, all that steam, or all that water turns to steam and creates a nice big hole in the middle that you can fill with pastry cream or some other type of cream, and customize in all sorts of various ways. So perhaps one of the pinnacles of my eclair technique was this eclair with a strawberry pastry cream and a basil white chocolate ganache. Um, thank you. Um, and so here it's again like some of the very standard techniques of choux pastry, pastry cream, ganache, but with like some variations on top of them. Um, so one thing, so I guess French cooking is also very modular. Like you have mother sauces that then you use as bases to build other sauces on top of. But as opposed to cooking with those sorts of things, when you're baking, it's a lot harder to do things on the fly. You really need to be making precise measurements as you go along because you can't really taste things as you are adding ingredients. If you mix 5 white powders together, like it's hard to tell exactly the ratios in which you added them, and so you kind of just have to know how much you added in the first place. So as perhaps one of the low points in my eclair career, I ended up with this. And so here are the three primary components you can see failed each in their own spectacular ways. For one, the shoe shell itself rose and then fell flat again. The pastry cream is a little too runny, even if I could fill it in the first place. And the ganache, it's maybe a little hard to tell, but from the particular type of specular reflection it's doing, you can see that it is broken. It's no longer emulsified, and so it has a little bit of a greasy mouthfeel, which isn't great. And so in this case, it's possible that I made a bad measurement and it messed some of these things up. It's possible that it was something about my technique that I did wrong and messed things up, but I won't really ever know for sure. Um, and so that got me kind of reflecting about these sorts of problems and how I might be able to make them a little easier for myself. And I realized there's kind of three problems I have when it comes to my baking. Um, so the kind of unifying theme around them is that I really enjoyed practicing the techniques of the baking, how to hold a pastry bag, how to recognize when the choux was done cooking on the stove. Uh, but I found managing the ingredients and measuring them to be really annoying. For one thing, I can memorize the motions, the technique of a recipe pretty easily and just kind of play it back by heart. But memorizing the numbers is much more a no-go for me. It's not the type of memorizing that I'm very good at. And then additionally, when I wanted to scale the recipe up or down, I'm sure a lot of you have had this experience of trying to keep track in your head of scaling each one as you go along, and then you accidentally don't scale one, and then that throws everything off. And that happened to me certainly. And then just keeping the state of have I added a given ingredient? When again you might have four white powders that all end up in the same bowl, is also kind of hard to do in your head. And so the obvious solution is to do what cooks and bakers have been doing for centuries, which is write it down. But I don't have the discipline for that. I don't like tracking that. Oh well. So these are all kind of little problems, but they frustrated me nonetheless. And so, like any self respecting programmer would do, I began daydreaming of solving this social problem with a technical solution. So I was just thinking, okay, what if I took something that is always on my counter? It's important enough that I dedicate some counter space to it, and it can measure things. And then I took something that's always in my pocket, and it keeps track of things really well. And then I made them play together a bit. Maybe this would be something that could help me out. And so I got thinking about building a piece of hardware. So the first step in my mind of how to build a piece of hardware is that very first thing, daydreaming, thinking about, okay, what is it that I actually want to build? Um, and then from there, you prototype. You just build something very hacky with off the shelf parts. See, okay, is this at all what I want to be doing? Is this something? And then my very real world word electronicate, where I kind of put some design work into building something out when I've decided on a prototype that works, and then I caseify by enclosing it in something that has the little functional properties that I need and goes along with the vibe that I'm looking for. And then finally I program it with the software that actually makes it run and does what it needs to do. Um, so certainly these all go in various orders as you're actually working on the project. It's not like it follows this linear order. Um, your prototype will probably need some sort of programming, for example, but this is a basic way to break it down at least. So having daydreamed, then I went on to prototyping. I took my kitchen scale and built a little prototype with a dev board that I could program with a display on it. and a scale sensor board, and then wrote a little bit of Swift to receive that in an iOS app over Bluetooth, and I tried it out. How do I feel about this? Um, so I put my very real baking ingredient on the scale and see like, oh yeah, I can make my phone read the scale measurement. That's kind of neat. It's kind of neat. So having done this, I thought about then, like, when I'm building a little hobbyist project, what do I try to prioritize? So, like, what are my principles of hobbyist development? Well, for one, I like to reuse as much as possible, especially when it comes to mechanical engineering. I do software. I'm not a mechanical engineer. I don't know how to like build a scale so that it's stable, and so want to reuse as much as possible. Um, then I want to keep it usable at all times so that I am constantly using it and getting feedback on like how is this useful, how can I change it, um, that sort of thing. Uh, you know, rush to your MVP and then keep it in a working state as you go along. And then the most important to me really is to embrace my little idiosyncratic desires that I have. Um, in order to stay motivated on a project, I find it incredibly important when I don't have any sort of like extrinsic motivation to see myself in it and to like have various things that, oh, if this were like a marketed product, maybe this would be extraneous or over the top, but it's something that I really care about, uh, and it's worth the like silly little effort or whatever. So let's evaluate my prototype on those metrics. For one, yeah, I'm using my kitchen scale. That's a pretty good point of reuse, which I'm pretty happy with. And I've kept it usable, which is particularly important considering I have just cannibalized my kitchen scale and still need to use it to measure things. So I have it still just displaying the weight on the display. So even without my phone, without the app working, that works just fine. Um, but does it follow my like little desires? It just doesn't feel right. I Baking's a fun hobby for me. I don't care about optimizing it totally, and like I don't want to be distracted by my phone. I don't want the endless possibilities of my phone. I want something a bit more constrained. So let's go back to daydreaming. What if instead of like managing all of that state on my phone, I could just manage the state on the scale itself? I don't think I really need to put that much on the scale, just like, oh, kind of, the current thing that you're working on and then move on to the next thing. So what if I just use this nice display that I have anyway to um, put the recipe on there? So I could continue trying to describe what was in my head, but I ended up building it. And so I figure maybe actually the easiest way is to just show you. So let's show you what's going on with this. Okay, so let's, do some daydreaming. So I want to like keep it usable as possible. So when you first turn it on, it should just act like a normal scale. So you can use it to just totally replace your scale in your kitchen. So yeah, when you turn it on, you can just measure whatever it is that you want to measure, and it tells you how much it weighs. It's still a scale. Let's say I actually want to bake something tonight. We can look at the recipes that I like frequently make, or some of the just like recent things that I've been working on. Um, so I think let's do a focaccia tonight. I guess well, on the one hand, there's a lot of people here, so maybe I should try to do a 4x recipe, but I'm not sure that this bowl will fit a 4x recipe, so let's actually just go back to a 1x scale. And Yeah, feeling good about this. Let's start making this focaccia. So I'll add some flour, good classic focaccia, flour, water, salt, yeast, and olive oil. So it tells me I need 500 grams, and I can see this nice progress bar filling up. And so I'll get up to 500 grams. Oh, that's a bit too much. Okay, let me get it back down to 500. Okay, that's close enough. Okay, but okay. I want to keep myself in a flow state, so to speak. And so let's imagine I can just go to the next ingredient super easily. Um, let's just press the button. Cool. All right. So next thing, salt. Yep, that makes sense. So let's do and see the progress bar fill up. And okay, a little too much again. Playing it fast and loose. But that progress bar is really nice because it means I can kind of calibrate my flow rate to it and see like, okay, I'm pouring in at a certain rate and then lets me like, yeah, get some, calculate my, calibrate my PID loop a bit better with some more information. Okay, so let's, the next ingredient is water, but I've made focaccia a million times. I don't, I know I have to mix the dry ingredients at this point, so I'm gonna mix the dry ingredients up. Okay, and I've left the whisk in there, so let me just re-zero it. And now a bunch of room temp water. Let's hope I've got enough. Hmm. This one's a little more annoying to go over with, so. Okay, good enough. Cool. All right, and then I have to mix that up as well. And now is the point at which I have to decide, do I want to move on because this, like, I've shown you the point of the demo, or do I actually want to, like, at least get this dough to a state at which I can actually make focaccia out of it? I think I don't want to waste food, so. Luckily, this needs to rise for a while, and so I can bring it home. I'm afraid I won't be able to share it with all of you very easily then, but some people will benefit from this. That's pretty good. It's my side. The olive oil. Oh, okay. Well, it'll be a little more enriched than it should be, but I think it will still be edible. Okay. This can be a little more annoying to work. What have I done to myself doing a live demo? I think it's good. Not the most well mixed dough, but you know, focaccia is not known for needing a ton of finesse, so I think it'll be fine. Okay, thank you for indulging me in that. um, yeah, so this was my very first prototype of that idea. It had the exact same parts as my first prototype. It had a dev board with a display and a scale sensor board. Um, but here is just displaying a Figma mockup. There's no code behind this. It doesn't even show the actual weight, but it helps confirm my hypothesis that this is actually what I want to build. I do some play acting with it in the kitchen. I get some bowls out, put it on there, pretend the display is changing, and see like, oh yeah, this feels pretty good. This is what I want to build. Um, so at that point, I decide, okay, let me actually not productionize this exactly, but make it so that it will actually fit all on in one place and not have a bunch of wires going everywhere. So the first thing when you're making a hardware project, in this day and age at least, is to decide on your central dev board. So a dev board is something that has a processor and some sort of peripherals on it typically. So maybe like the best known one these days is a Raspberry Pi. That's one that actually runs Linux, but still has a lot of peripherals on it to do with what as you please. In this case, I knew I wanted to go with a much smaller type of microcontroller called an ESP32, which uses a lot less power and boots more quickly because it's not running Linux. Um, and so dev boards at their core have a processor, but they can also have things like a display and some buttons. A company that I like that makes a lot of good dev boards is LilyGo. They make things like BlackBerry clones with ESP32s on them. They make e-paper boards with ESP32s on them. And they also make e-paper Blackberries. But even more importantly than an e-paper Blackberry is they make a lot of dev boards with weird aspect ratio displays. They make these circular guys. They make these square guys. But most importantly, they make really, really long guys. Just like, look at that. Think of just like the fun things that you can do with a ridiculously long display. Like, every time I go on a subway platform and see the like long skinny display showing me the time of the next arriving train is just such a source of joy. And so I decided to follow my little whims and indeed choose a not quite so ridiculously long, but still pretty ridiculously long display. It's also very high DPI and has nice, brilliant colors because it's an OLED display. Um, and here, that's really highlighting where, like, um, in a production quality device, like, that's maybe not what you would optimize for. You don't need super fancy animations on your scale, but I want super fancy animations on my scale. That's what I want to optimize for. So let's optimize for that. But this is also a very easy board to work with. Its schematic is available, questionably open source. Lily goes a little weird in that context. Yeah, but perhaps open source, at least available. Um, which lets me kind of do some sanity checks down the line. If something's not working, I can correlate the electronics a bit better. Um, it has example code that is kind of different than some other vendors' types of example code because it like uses more realistic frameworks as opposed to the kind of like get started easy, but then don't really scale up. They have ones that are like uh, perhaps more realistic in that extent. To that extent, and all things considered, it's pretty cheap. It's $30, which for a display kind of that nice is a very good price, and it has a chip that I really like on it, the USB 32S3, which has lots of processing power to handle that display. So with that kind of like central dev board picked out, um, I started working on the schematic of what I would need on that board. And so designing circuits to like software engineers, which I would guess is probably most of us in this audience. So circuits can sometimes seem like a totally foreign world, uh, but they're when you're just doing things at the level of integrating parts, uh, it a little gets you a long way, right? Like I know that V equals IR, and I don't know much beyond that in terms of electrical engineering, but that's mostly all you need. So this is the schematic of the circuit. It's pretty much just listing all the major parts that I want. It has a spot for that LilyGo board that I picked out. It has a knob. It has a back button. It has a buzzer, so eventually maybe I'll add timers. Um, and then probably the complicated thing looking here is like is my scale sensor, but it has all these other things going around it, capacitors and resistors. Um, do I know exactly what all these are doing? Um, Not really. I like have some little inkling, but how I'd figure out these particular resistors and capacitors to use is I just copied and pasted from the schematic of the board that I used, which I am told is what real electrical engineers do. Is like a lot of your job is looking at the documentation for the part that you're using, finding the application notes section, and then just like recreating the schematic that's listed there in your own design. And of course, actual electrical engineers, I'm sure, have more critical thought in what they do, but copy and paste gets you a long way. Um, so then next down the line would be actually making the PCB. This is the printed circuit board that puts all of your parts together on one substrate. Um, it I love looking at these things. They're just super pretty, and I love taking the like just intermediate states of a project and appreciating them for the little beauty that they have. Um, and the process here, again, like can seem a little daunting, but you're basically just putting the parts down and then routing between them. I think of it as essentially playing mini Metro. When you have new stations pop up when you add a new part, and then you have to figure out, oh, now I have to get it there. But it's a fun puzzle to play. And again, if all you're doing is like integrating some coarse components, it's quite doable without a lot of experience. Um, so then I uh, send it off to a fab, pay them $20, and a week later get an actual circuit board in the mail. Um, and an actual electrical engineer would probably notice a few mistakes I made in this, but it works, so good enough for me. And then once that is assembled, I start thinking about, okay, now how am I going to build the case? Because I don't want to like worry too much about spilling a bunch of flour on my electronics or, God forbid, water. Um, so I want to build a case for it. Um, 3D printing has made this so much easier in the past decade. You don't need to think nearly as much about how you're actually going to fabricate something, and instead you can just describe what you want it to end up looking like and pretty much have that within an hour of going to print. Um, and again, this is another sort of case where like actually if you need tight tolerances, if you need structural stability in certain ways, it becomes much harder. I don't want to say that like mechanical engineers' jobs are now like over. There's no use for them anymore. It's not like that. It's like, you know, to do a little like it knowing a little gets you a long way. And so for programmers, I really appreciate this tool called OpenSCAD, which lets you design parts with code. You get to describe the kind of basic shapes that you have and then how you combine them using various transforms like unions and differences. Um, Certainly, once you start scaling up the complexity of the products you build, it becomes a lot harder to manage. But for a programmer, it's the type of paradigm that you're used to. You can check it into Git and do version control on your cases that easily. Um, and you can like import files and deal with things programmatically in ways that just, yeah, um, match up with the programming state of mind. And so then you send it off to your 3D printer at your hackerspace or at the Recurse Center, which has at least one 3D printer, and you get your parts. So, of course, the part now that we're perhaps most familiar with, which is programming it. Um, so you have to kind of pick your dev ecosystem. Classically, you would write these sorts of like microcontroller-y code in C, and you can still certainly do that, and that's something that is a choice that makes sense in a lot of contexts. Um, but I like to think that um, memory safety is kind of like the bar that I like to strive for in my languages, in all of the languages that I use. And so then another good option is MicroPython, which is wonderful for prototyping. It's a little slow, but gets the job done when you're just trying something out. But of course, my favorite, if you know anything about me, I love types. And so I love Rust on microcontrollers, where its type system prevents you at compile time from doing a lot of stupid things, from like sharing pins between different components because of the affine types that don't let you like just split things up arbitrarily. Um, and like it enforces mutexes on resources that get used in interrupts, essentially kind of like janky threads that happen on certain event callbacks uh, by its normal like sharing logic. And so one thing that is wonderful about the ESP32 is it actually has official support for Rust and a very nicely designed library for using Rust on it, which again is like a little source of joy of like I get to use my nice little programming language with strong types on a dev board, which is great. Um, I went with something a little more experimental for the UI. Um, since, again, I want those fancy animations, and there aren't that many things on a microcontroller that can that handle animations with nice full color displays and whatever. So I tried this new language library called Slint, which is a sort of reactive programming language for writing UIs, but it compiles down into Rust, and so it works on desktop where they have kind of like GPU-based rendering engines, but then also on embedded devices where they have a totally software-based rendering engine. But you can still test the UI on your laptop without having to recompile all the time, which is very fun. Unfortunately, it has a lot of the usual problems that you get when you mix reactivity with callbacks, which is like, oh, you have mixed state of like this callback updated this thing, and now the reactivity is broken, and so you get broken bindings where based on the like kind of initial data flow, it looks like this when you change something over here, it should affect the binding over here, but it doesn't actually because of various broken things. And then, anyway, um, I hope that they eventually resolve some of these things, but we'll see. Um, oh yes, it compiles down into Rust. It's nice to see. Um, so as I was doing all this, my motivation very much came in fits and spurts. And so this is a my commit log in my repo over the past year, which includes all the CAD and everything because it was all code. Um, and I think this is something that initially I felt pretty bad about. It was like, this is a fun project that I'm excited about. Why can't I get myself to like work on it consistently? But I eventually came to learn that like, no, if I don't feel bad about getting back to it, I will get back to it eventually. It's just like a software project that you pick up every now and again. But here I had the constant reminder of the scale in my kitchen that I used that made this like even easier to remember to get back to. But that's where the kind of like meeting my particular desires that are maybe a little unusual came in handy for motivating me. So now, if we were to get back to the start of the cycle again, in terms of where I want to go from here, right now, the way that you add recipes to the scale is you have to edit the source code, recompile the source code, and re upload a whole new firmware image. This is not the most ergonomic, um, but I cook a lot of or I bake a lot of the same core things. Like I said, I remember the techniques in my head, um, and there's only so many of those that this is true for, and so it works okay. But I'd still prefer something better. I'd like to have better docs so that more people can build them if they are so interested. And long term, I want to make it usable for doing recipe development. Um, because I like to veganize a lot of recipes. I'm not vegan myself, but I have a lot of vegan friends, and that requires a lot of like trying different substitutions, trying different ratios of things. And I have this idea of being able to record the measurements that I take since I've already hitting the next button when I'm done adding something, and then being able to correlate the results of what I bake to those measurements. But in the meantime, like even without those pie in the sky dreams, like it's brought me a lot of joy in my kitchen. I use it like at least weekly for something that I bake, not including all the times that I just use it as a normal scale. Um, and like using something like that all the time that I'm really proud of, like just makes me happy all the time. I think there's been lots of software projects that I enjoy the development of, but then don't actually use, and that's its own sort of fun. Like I certainly have no qualms with that, but it's a different type of fun that uh, for something that you do actually like use all the time. Yeah, so I love that about it. So here's a couple more things that I have baked using it. Um, in the kind of recipe development idea scheme, I did some A/B testing between vegan and non-vegan cream puffs to see like, okay, what are the distinctions there? And really making sure that, okay, I keep everything the same except for my one ingredient, and it helps me keep track of that. I've also baked a flan using it with again, the standard components of a pastry cream and a pie dough that I have programmed into it. And today, I baked some Biscoff cookies with a little custom cookie cutter I printed with, a nice little octopus emoji on them. And I don't have enough for everyone, unfortunately, but I have some here that you're welcome to see and welcome to have afterwards. So at this point, like, I want you to think of your own hobbies. What is it that you do in the real world that you do with your hands that might benefit from some sort of little electronics project? I hope that I've communicated that building projects on this scale is a lot easier than I think some software people tend to think of it as. And having something that you made with your hands is a wonderful feeling that we as software engineers don't experience all that much in our like day jobs. And so to experience it at home or in a hackerspace is a wonderful way to get some of that. And even if I haven't inspired you to build an electronics project, at least like do some like have make some sort of creative thing with your hands, like crochet a sweater, make like wire wrap art, something like that. Because there's just something really special about that. So at this point, I want to thank some people. Um, my family who helped get me in this mode of thinking in the first place, but especially my dad who got me interested in electronics in the first place and has been sort of a source of advice for some of this project. Um, my wonderful friend Avi, who got me into French baking in the first place, and we baked a bunch together, and I have loved it ever since. Um, Two of my college communities, Pika and Tetezu, who encouraged and consumed a lot of my baking. Um, NYC Resistor, which is my hackerspace, not too far from here, that had a lot of that offered me a lot of tools, but also so much support and encouragement through it. And of course, the Recurse Center, not only for giving me this opportunity to talk about this, but also for help giving me the confidence that what I build is interesting, and for giving me a community here in New York that has offered me both a lot of excitement and a lot of friendship. So, thank you.
So we have a little under 15 minutes for some questions if anyone wants to ask.
Hey. The question was, have I thought of adding a battery? And the answer is definitely yes. That's probably the first thing that should really be on that slide of future work. Um, it's something that, yeah, I keep meaning to get around to and have never gotten around to. So hopefully one day. So the question is there anything that hit the cutting room floor or that I thought would work and but didn't? Um, I think Um, so, well, as I explained, the first thing that hit the cutting room floor was the kind of like phone integration. In terms of this revision of it, um, um, I guess the main thing I would say was like, and not that this is totally out of the picture yet, but I'm still a little frustrated with the frame rate of it. It's still like not nearly as smooth as I would like it to be, and I've done like a decent amount of work to get that down, but it's still not there, and so that's something that I've given up on for now. um, yeah, but that's most of what comes to mind. So the question is, do I have any advice for getting over your scope creep and ensuring that like you finish the project? Um, and so I guess first I'd like to push back on the premise a little bit insofar as like this doesn't feel finished to me. Like it's not done. Um, but I've kind of embraced that it will never be done, but it will always be usable sort of philosophy. Um, and I guess that's easy to embrace when it comes to the firmware, to the software side of things. When it comes to like, oh, cutting the first version of your PCB, that's certainly a little harder to push yourself to say like, okay, this I just want to get this done. Um, I think my advice there would be to like just like find some sort of natural deadline, whether that's a talk you want to give about it, or the onset or re-onset of some tariffs coming up, and you want to buy parts before then, or something like that to just like make sure that um, you have some pressure to get the initial version there, um, and just treat that as a real deadline, and then go from there. Mhm. Um, yeah. So the question was about since I used my existing scale, did I have to do any reverse engineering, and could I have gone back to my kind of original scale if I wanted to? Um, and the answer is I had to do just a little bit of reverse engineering. I suspected from like descriptions I'd seen on scales online that if I opened it up, I'd primarily just see the four wires to the like load cell Wheatstone bridge configuration, which I should have had a backup slide for, but I don't. Um, which is like the standard way of measuring force in a scale or another sort of setup. Um, and I guessed that since it seemed like all of the logic could just be in the main board at the front of the scale, um, that probably all of it would be. And so, like, just there would be the analog wires for the Sweetstone bridge going back and forth. And that assumption was correct. And so, the only reverse engineering needed was guessing which color of wire was which of the Wheatstone bridge. But there's only four wires, and so that's only 16 possible, or it's not even 16 possibilities. What is it? Four permute four? 24? Thank you. Um, yeah, so and in terms of whether I could have gone back to my original to like just the stock scale, yes, I could have it just required desoldering some wires and soldering them back to the original board, so could have been very doable. Yeah. Um so I think um for the like dev boards, that was something where um I had played with this like home automation software called Home Assistant a decent amount, and a lot of people in that community were excited about LilyGo boards, and so I could see there like, oh, like a lot of people think these are great boards to like base things off of, so I could go from there. Um, there, um, then for the UI framework Slint, um, there I was very much like, well, I was already in a Rust headspace, and so in terms of looking for like, okay, what are the Rust UI frameworks that work on embedded platforms? Was like, well, it's basically just like render rectangles yourself, um, uh, or this one, and so like. And in this case, I found it, yeah, through some Googling, more or less. Uh, yeah, and then like some of the I guess tooling for other parts like OpenSCAD and KiCad, which I guess I didn't mention for designing the schematic in the PCB. Um, uh, OpenSCAD, I think I probably saw on Hacker News at some point, um, and like that code-oriented design philosophy, and so just ran with it from there. And then KiCad, I think, is like um, the de facto free and open source PCB designer. So that was also kind of, yeah, a good just default. I don't know what I want. I'll just use the one that's everyone else seems to be using. Mhm. Okay. The question is there a detail about the way that it works that brings me particular joy when I use it? Um, I think um, um, knowing the um, like seeing the scrolling work on the ingredients as you like click next and you measure ingredient and click next. Um, because Slint doesn't have any way of doing lazy loading of lists or something, and so my first revision was um, just like having one of those widgets for each ingredient, which it did not like, despite like nominally claiming to not render things outside the view context, but in practice it seemed like it always was, which then made it very slow. And so writing my little um figuring out a way to use their animation system while doing while only having um like two different contexts that I switch between um was a lot of fun to figure out how to do. And so now every time I just see it go down and see it look like it's just a normal infinite list or something, I enjoy seeing that animation work. Mm. Um, so the question is when like monitoring something at which like you're pouring at a certain rate, you need the scale to react somewhat quickly to um, be able to adapt to that. Where does the latency come from in terms of hardware or software or whatnot? Um, and I think the answer is that it primarily comes from hardware and the kind of like just physical springiness of it. Um, and then also in the analog to digital converter in the like what I just called the scale sensor. Uh, inevitably has some noise versus latency trade off. Um, I think usually it's not so much on the like displaying it side of things, and it's more like those two sources. Okay, time for one or two more questions. You had a question. So the question was about how I say that I remember the technique of what I need to do, but have I thought about adding instructions so that if I forget, I don't have to like rely on some sort of backup or mess something up? And I have thought about doing that sort of thing, but I've uh, decided fairly explicitly not to, both for the like the two reasons of first of all, it would make the UI a lot more complicated, I think, and you'd have to like maybe scroll through more things, and that would kind of be annoying. But also, I like the kind of like I don't know, perhaps sense of expertise it imparts upon me. It's like, oh yes, I know what I'm doing. Like there's this one part of me that I want to augment and nothing else. And so I like kind of explicitly don't want to like de-skill the task of baking in the ways that I don't like, or that like would then make me feel like I'm a bit more rote or a bit more robotic, and instead just want to be augmented in the ways that I want to be. And so I think that's why I've like decided not to do that sort of thing. Yep. Okay, last one. So the question is essentially, have I thought about doing baker's percentages, where you put in one ingredient and then the rest of the recipe scales according to that? And the answer is yes. I've definitely thought about that, and like it shouldn't be that hard in terms of like, oh, just add another like a like auto scale to the scale section, um, and yeah, that's something that would be fun, especially for the more like bread oriented things. There are some that like you include eggs, in which the measurement for eggs says like, oh, 100 grams of eggs, and I know in my head a large egg weighs 50 grams, and so I know that's 2 eggs. But if I scaled based on something else, eventually I'd have to do like 1 2/3 eggs, and that would annoy me. So there's definitely some where it makes more sense than others, but yeah, that is something that I would like to have. Okay. And then could I just say something about um so if you want to see more of the scale up close, you're welcome to come up afterwards and see. I also have some kind of dissembled parts of it, so like a PCB with just the parts on it, and the module and the components of the case. So if you wanted to see the parts of it, you can also see that after the fact.